Hi everyone, this is the video lesson for 6.4, Properties of Vectors. Here's the warm-up. Number 1, state the commutative property of vector addition. So the first thing we're going to do is write down what this property is, and we're going to illustrate this with a diagram. So A plus B equals to B plus A. So when you're adding vectors, order doesn't matter. And the best way to understand this is draw two different vectors. So let's start with the fact that we have A and B, and we'll add a C vector, which we'll use later on. Let's label these A, B, and C. So if you think about the left-hand side, you're starting with vector A, and I'm going to demonstrate the triangle law. So I'm starting with A. I'm adding it with B. Again, because I'm using the triangle law, you're connecting it from head to tail, which means the resultant vector is going to go from here to here. So that becomes A plus B. If you look at the right-hand side, we start with B. And again, I'm still going to apply the triangle law. I'm just going to copy and paste this. Let's put this at the bottom here. And vector A and again, if you draw the resultant vector, it goes from here to here. So again, if you draw this, you would discover that left-hand side and the right-hand side are the same, as expected. And again, we know these are equal vectors because they contain the same magnitude, and they're pointing in the same direction. Number 2, state the associative property of vector addition. So in this case, we're adding three different vectors, A, B, and C. And the point we're trying to make here is that if you added A and B first, then you add to C, this is the same as saying adding B plus C, then adding A on top. And again, I want to demonstrate this graphically. So we start with vector A. It's going to be right here. Likewise, vector B. Right there. Now this is the same as number 1. So again, you're starting from here all the way to there. That's going to be A plus B. But don't forget you're adding C on top. So I'm going to move this diagram over so you can see the entire diagram. C is going to be here. So now if you're adding vector C, again applying the triangle law, the resultant vector, let's put this in a different color, it's going to go from here all the way to there. Right, so that's going to be A plus B plus C, and I'll put brackets there. Now if you look at the right hand side, we're expecting the same outcome. Now of course you're adding with B and C first, so I'll start with B and C. B, added to C, and again applying the triangle law so far with B plus C. So that's B. I'll just write it here, B plus C. Now you're adding A on top. So again, I'm going back. A is going to be added to the front. So I'm keeping it in the same sequence, A plus B plus C. So A is going to be there. And again, in the same color as the first case, A plus B plus C equals to the same as the left-hand side, as expected. Okay, so again, just like the commutative law, if you're adding three vectors, order doesn't matter. You can add the first two or add the last two, and the final resultant vector is the same. Number 3, state the distributive property of vector addition. So this means if you take some scalar multiple k and you multiply this by a plus b, this is the same as saying k multiply by a plus k times b. And of course, k is an element of real numbers. So I'm just going to pick a number, right? So let's say k is 2. And k could be any real number in general. What we can do is we can go back and we're going to go a bit faster now. We know what a plus b looks like. So I'm just going to take that from question number 2. And now, instead of saying a plus b, we can draw 2 times a plus b. So it's going to look something like this, roughly. Okay, so that's going to be 2 times a plus b. And if you look at the right-hand side, I'm looking at 2a plus 2b. And again, we're expecting the same answer. So I'm going back. I'm taking a, except I'm going to multiply this by 2. So it's going to look something like this. Maybe we'll put it here so everything fits. I have 2 of these. Plus 2b. So again, there's b. And another vector b. And again, as expected, the resultant vector, which is going to be 2a plus 2b, is the same as the left-hand side. And again, it doesn't have to be 2. You can pick any value for k. I just picked 2 so you can see the magnitude as you're comparing them. Now, number 4. State 3 further laws of vector addition and scalar multiplication. Hint, adding, associative law for scalars and distributive law for scalars. So 3 additional concepts. Let's write this down. Number 1, if you're adding a 0 vector, you can simply state that any vector plus a 0 vector equals to that same vector. So a plus 0 becomes a. Number 2, if you state the associative law, you can say that m times n times a equals to m times n times a, or you can take m times n times a. So again, the idea is the brackets could go in different places and it will give you the same outcome, right? And again, m and n are elements of real numbers. Number 3, if you think about the distributive law, this states that m plus n times a equals to ma plus n times a. So that's the warm-up. And again, this lesson is fairly straightforward. A lot of you have done grade 10, grade 11. You might be doing grade 12 advanced functions concurrently, but it's very doable. So number 1, simplify the following expression. All we're doing is we're expanding this, right? So if you pretend 2 times vector a is just 2a, like you did in the past, then that's how you do it. So you write down 2a plus 2a plus 4b minus 6a plus 3b. Again, here comes the final answer. We're going to collect like terms. With a lot of practice, you can do all this mentally. I'm still going to circle them for you so you can see exactly where these answers came from. So 2 plus 2 minus 6 is negative 2a. Likewise, if you look at 4 plus 3, that's going to give you 7. So the final answer is going to be negative 2a